Hello students, next we'll go to the second half of Banker's algorithm, that is resource request algorithm. So this particular algorithm is used to check whether the new request that has been asked for from a process, whether that can be granted or not. If now suppose a process P1 is asking for some additional resource, whether that resource can be given to that particular process. If it can be given, whether your system is still in a safe state or not. So for checking that, we can go for resource request algorithm. Okay, so here we are using a vector, that is the request vector for process Pi. So request of I. Okay, suppose we are speaking about process P1, then it is request of 1. Which process is asking for that particular process, you have a request vector. Okay, so you can see, if request of I of j is equal to, so I'll write over here, if request of I of j is equal to k. So what is the meaning of this is, process Pi, so this I is nothing but representing process. Suppose process P1 will assume. So this I value will be 1 now. Okay. So process P1 is asking for a resource. This J is representing the resource type. Okay. And K is representing the instances. So according to this, process Pi is asking for resource type J. How many instances? K instances. Assume a resource is printer. So process P1 is asking for printer. How many number of printers it want? Suppose 2. We'll assume it as 2. So that is the meaning of this. Okay. The same thing is given here, made by process Pi. Then the following steps need to be done. So what are the steps? So first thing, that is step 1. If request made by process Pi is less than need, how much it needs. Okay, if it is less, so suppose you require 5, okay, but you have asked for 2, then go to step 2. In step 2, what you're doing the next step, that is request of I is less than available of I. Available is nothing but how many are there right now. So suppose 5 are there and you're asking for 2, then it can be given. Okay, that 2 resources can be given to you because 5 are there. In 5, 2 resources can be given to the process. Then you're going to step 3. In step 3, what happens? System wants to allocate the request asked for. In that case, these 3 steps you have to do. What are the 3 steps? Available is equal to available minus request. So available is nothing but how many are there right now. Suppose you assume 5 resources were there right now and Pi has asked for 1 resource. Then what happened? Available minus request. So 5 minus 1. So right now how many will be available now? 4. Okay, that is first thing you have to do. Next is allocation of I is equal to allocation of I plus request. So allocation is nothing but how much resources allocated to the process right now. Okay, so right now you assume 4 are allocated to the process and now process is asking for 1 more. So 4 plus 1. So now how many will be allocated? 5. Okay, so remember available is available minus request because 5 were there, in that 1 you are giving, so it is minus. Whereas allocation is nothing but already 4 was allocated to a process, now it is asking for 1 more. So allocation, that is add. Okay, now need, suppose it wanted 4, you assume, and now 1 is given, so again it is minus. So previously you required 4, now what happened? You requested and that request is granted, then 1 is given to you. Okay, you wanted 4 and you asked for 1, that 1 is given to you. So now how many more you require? You require only 3 more. Okay, so these are the 3 steps what has to be done. After doing this, you have to once again use a safety algorithm and check whether the system is in safe state after doing all this. So suppose a process asked is P1, you assume. So what happened now for P1? Available you have changed, allocation also changed, need is also changed. So using this change value of P1, once again you have to do this safety algorithm. All the steps you have to do. After doing that, if you're getting finish of I as true for all the process, then you're saying that system is in safe state. And then you have to write a conclusion as the request can be granted. That is here. Request can be granted safely. So this is when request can be granted. Okay. So we saw till here step 2. Now in case this is false. Okay. If request is greater than need, then in that case what will happen? Raise error condition since process exceeds the maximum claim. So initially we said, right, initially you have to tell how many, process has to tell how many number of resource it requires. So suppose initially it has told 3, but now request, it might be requesting for 5. In that case what happens? This condition fails. In that case error should be raised. Okay. And why the error should be raised? Because it is asking for more than what it claimed for. Okay. That is in case if this is false. If this is true, go to step 2. In step 2 what did we do? We check for available. If this is true, we went to step 3. Now if this is false, that is request is less than available. Available means what? Currently how many are there? Okay. So if this is false, then what you have to do? P1 must wait since resources are not available. So right now it is not available, but some point later some other process which was using the resource, it might release. That time it will be available to you. Okay. So for that purpose, for second step is process has to wait. In first step, if request is greater than need, then directly raise the error condition. Okay. Then finally the last 3 steps. I hope you have understood this. For available, you're minusing request. Why? Because 5 were there and it is requesting for 1. Then what happened? Available will be less. It is reduced. Means you have given 1, then it is reduced. Whereas allocation is 4 were already there and it was asking for 1 more and it has got that 1 more. So it is add. Need is, initially you are telling need is 4 and requested, and that is granted, then it will be need minus request. Okay. So to do all this modification for whichever process has asked for, you have to do, and once again you have to use a safety algorithm. That's a safety algorithm and solve once again. If the system is in safe state, then the request can be granted. Okay. So this is your banker's algorithm, where you have safety algorithm as well as resource request algorithm. In the next video we will see how to solve this banker's algorithm. Thank you.